Hello, Bronx Middle School Math. We are continuing with multiplication and word problems. So this is going to be Unit 1B, Lessons 1 and 2. So we're going to do some practice problems in this video, and you have seen these problems in class examples. You've seen these problems in your exit tickets, homeworks. I'm just doing these problems here so that you can see a way to do them and model them for your notes. Please, scholars, the notes are your responsibility and they are your tools that you're going to use to complete your homework, complete quizzes, exit tickets, to study for the exams. Your notes are vital to your success in middle school, high school, and university. So let's start forming those practices now. Take good notes. Make sure they're organized. All right. So remember, the standard algorithm is multiplication in the classic way. Please go watch these two videos if you have not. These videos, I like them a lot because they use these graphics you see like right here that I'm not an engineer, I'm not a computer engineer, I can't code, I don't know how to do these types of graphics. So it makes it really clean and easy layout to understand. So go watch those videos. I'll put the link in the description. They are not my videos. I do not know who made them, but they are good stuff. So go watch them. Anyway, so let's begin with some practice problems. So look at the area model picture below. What are the values of A and B? Okay, well, let's find A and B. We got A right here and B right there. So take a few moments to try and figure out what you think A and B would be. So with an array model, we know you multiply this with this, or this with this. So let's do that to figure out what B would be. I want to figure out B first because that seems to be easier for me. So I'm just going to multiply 30 with 2, and that's going to give me B. So I could do 30 times 2, or I could just add 30 twice. And I know it's going to be 60. Okay, but now I'm trying to figure out A. And I would multiply whatever number is here with 20 to get 60. So what would I need to multiply with 20 to get 60? I could put 60 over 20 equals, and then 20 goes into 60 3 times. So if I say A is 3, oh, why did I just write A next to A? I'm sorry. If I say A is 3, let me check that. So that works in this situation. But does it work in this situation? So 3 times 2 equals 6, and that checks out. So A equals 3 and B equals 60. Always check your work. Oh, wait, I didn't finish the problem. Excuse me. What digit is in the tens place of the product? Well, the product is the answer. So remember how we did the vocab in the previous video? So the factors of this problem would be 133 times 22. Those are our two factors, and the product is going to be the final answer. So let's add up these components to find the product. When we add up all the numbers from the array, we get 2,926. That is the product. But which one is in the tens place? Well, that's going to be the 2, which represents for the 26. So the number that's in the tens place is 2. We did these multiplication problems in the prior video, but we could do them really quickly right now just so that we can get some practice using the standard algorithm, which can be found how to do in these two videos. So let's begin with 109 times 7. So I'm going to start in the ones place. So 7 times 9, that equals 63. And remember, I would put the 6 there, but that's in the way because that's going to be in the way when I do the tens digit. So I'm going to put it in the added. Not the attic, the added. We call it the added instead of the attic because we put it here for storage and then later we're going to add it. Yeah, I know. I'm sorry. Puns are rough. So we're going to put the 6 there and leave the 3. Now let's do 7 times 0. And that's 0. Y'all know that. But we're going to add the 6. And then we're going to put the final answer there. Now we only use it once, so we're done with that 6. Now 7 times 1, that's 7. And since the 1 is in the hundreds place, the result also needs to be in the hundreds place. So the final answer is 763. 129 times 7. Let's do this one. We're going to do the same thing. Start with the ones place. 7 times 9. Oh, I put 6. My bad, y'all. 7 times 9 equals 63. And remember, the 6 would be in the way for the tens digit. So we're going to put it in the added. 7 times 2 equals 14. But I still have the 6 from the added. So that's going to be 20. But wait, that 2 is in my way for the hundreds place. So I'm going to put it in the added. But I'm leaving the 0 because it's not in the way. We just use that 6, so we are done with it. Now it's time to do 7 times 1. That's 7. And I haven't forgotten about that 2 in the added. 903. Good job, y'all. Now we're switching it up a bit. We're going to do 242 times 8. So we begin with the ones place. 8 times 2 equals 16. The 1 would be in my way, so I'm going to put it in the added. Now we're going to do 8 times 4. But wait, I still have this 1. There we go. Now I could scratch that out. But this 3 is going to be in the way when I do the 2's because that's in the hundreds place. So I need to put it in the added. Now I'm going to do 8 times 2 again. 16. And I still have that 3 in the added, and that's going to be 19. Now I can leave this 1 here because there's not a number right here, so it's not in the way. And our final answer is 1936, or 1936. Let's move on to 60 times 5. 60 times 5. We start with the ones place. 5 times 0 equals 0. 5 times 6. 30. And remember, I can leave this 3 here because there's nothing in the way. 264 times 5. So start with the ones place. 5 times 4, 20. But that 2 is going to be in the way of the tens place, so I'm putting it on the added. Now we're going to do 5 times 6. That's going to be 30, and I have that 2 from the added, so it's going to be 32. But that 3 is going to be in the way of the 2, so I'm going to put the 3 in the added. Now we're going to do 5 times 2. That equals 10, and I'm going to add the 3 from the added. That equals 13. So our final answer is 1,320. Let's get a nice overview of that page. I hope you are taking notes because you can quickly refer back to these notes when you're doing your homework, when you are studying for the assessment. Make it easy for future you to study. Okay, now for a word problem. Remember, when it asks for a product, that means it's asking for the final answer. So don't let these mind games that word problems play have an effect on you. Let's begin. Cannon and Denzel were both estimating the area of a new rug their teacher bought for the classroom. Cannon said the rug was about 20 feet wide and 25 feet long. Denzel estimated the rug was 21 feet wide and 24 feet long. Will they end up with the same area? Why or why not? Was one's estimated area larger? If so, who and how do you know? Is there a way you could prove it without using math? Wow, we have a lot of questions in this one. Let's count the question marks. 1, 2, 3, 4, 5. Gosh, we got 5 questions to answer here. Well, let's start with area. I know y'all know what area is. So area is the amount of space within a shape. So perimeter would be around, but area is inside. So they want to figure out the area of this rug. And so they're using their estimates. What's an estimate? An estimate is an educated guess. You're using logic and what prior knowledge to estimate, to guess. Because if the difference between a guess and an estimate is that a guess, you're not using any knowledge or logic. But an estimate, you're saying you're using prior knowledge to be like, well, a foot is about this big, and that looks about 20 feet. So I'm going to say 20 feet. But if they knew exactly, so it wasn't an estimate, that would be if you measured it and you knew for a fact it was 20 feet. So they haven't measured it yet. They're just looking at it and using their prior knowledge of, well, I've seen a rug and that other rug was 20 feet and this looks about the same. So they're estimating. It's an educated guess, as some would say. You're using logic and prior knowledge to estimate. So let's begin. So remember area, let's get our shapes. Area is the space within it, not around it. Perimeter is when it's around. Area is within. So let's do, this is going to be Cannon's rug. And they said 20 feet wide and 25 feet long. And then Denzel estimated that the rug was 21 feet wide and 24 feet long. But how do you find area? Well, this is the width and this is the length. So to find area, you multiply the width and the length. So we are going to multiply these two factors, width and length, to find the product, the area. So let's do Canon first. He said that it was 25 feet wide by 20 feet. There we go. I'm sorry. He said 25 feet long by 20 feet wide. And Denzel, am I spelling it correctly? Yes. He said 24 feet long and 21 feet wide. So who was going to have the bigger rug? Who's going to have the smaller rug? Well, let's multiply. And of course, since we are using the standard algorithm, we're going to use the standard algorithm. Since we're learning the standard algorithm, we're going to use the standard algorithm. So let's do that over here. I'll use cannons over here. So check your work. 25 by 20. So we start with the ones. 5 times 0, 0. 0 times 2, 0. Okay. Now we're going to do the tens spot, the tens place. And since we're dealing with the tens, we're going to put a placeholder so that we know not to mess with the ones place. Because we already did the ones place with this one. So now we're in the tens. 2 times 5 equals 10. But this 1 is going to be in the way. So I'm going to put it in the added. 2 times 2 times 2 equals 4. Y'all, I'm having trouble today. 2 times 2 equals 4 plus 1 equals 5. So the total area for Cannon's rug would be 500 feet. Let's do Denzel's now. We're going to do 24 multiplied by 21. Now we start with the ones place. 1 times 4, 4. 1 times 2, 2. I know that was too easy for y'all. Now, since we're doing the tens place, this 2 is in the tens place. So we're dealing strictly in the tens. That's where we begin. So we're going to put the 0 as a placeholder. 2 times 4 equals 8. 2 times 2 equals 4. Now let's add these up. 4 plus 0, 4, 10, 504. So, even though there was a foot difference, so look here, Cannon's, his was a foot bigger in length, and Denzel's was a foot bigger in width. So you would think, oh, well, They each have one that's larger, so it evens out. Nope. Look, we know now that Denzel, his rug estimation was larger than Cannon's. Denise decided she had not planted enough flowers, so she increased her garden size. Her garden is now 54 rows of flowers with 18 flowers in each row. All right. But Denise has a sister, Audrey, and Audrey has her own garden with half as many rows but double the flowers in each row. How many flowers are in Audrey's garden? I'm sensing some sibling rivalry here. Let's begin by figuring out how many flowers Denise has in her garden. So she has 54 rows with 18 flowers in each row. So let's multiply that. These are our two factors, and the product is going to be the total amount of flowers. So we start in the ones place. 8 times 4, that's 32. We're going to put the 3 in the addit. 8 times 5, that's 40. And we're going to add the 3, 43. Remember, I put that place 0 there because now I'm in the tens spot. So 1 times 4 equals 4. 1 times 5, 5. Now I'm going to add these up. So Denise has 972 flowers in her garden. Okay, now Audrey, let's figure out this sibling rivalry. Who won? Who has more flowers? So Audrey, she has half as many rows but double the flowers. So half as many rows. Let's begin that. So Denise has 54 rows. If we wanted to figure out half, we would divide it by 2, which equals 27. But she has double the flowers in each row. So 18 times 2, and that's going to give us 36 flowers in each row. So let's review. Half as many rows. So Denise has 54 rows. Audrey has half as many rows. So 54 divided by 2 equals 27. Audrey has double the flowers in each row. Denise has 18 flowers in each row. If we want to double that, we multiply it by 2. 18 times 2 equals 36. So now, if we want to figure out the total amount of flowers that Audrey has, we are going to multiply her rows by the number of flowers in each row. And then we can compare to see who has more total flowers. So we begin with the one spot. 6 times 7 equals 42. And that 4 is going to be in the way, so I'm going to put it in the addit. 6 times 2 equals 12, plus 4 equals 16. I can get rid of that 4 now because I've already used it. Now, let's do the tens spot. We put a 0 as our placeholder since we're in the tens. 3 times 7 equals 21. That 2 is going to be in the way, so I'm going to put it in the addit. 3 times 2, that's 6, plus 2 equals 8. So let's add these different product values. That equals 972 flowers. Who had more Whoa, okay. Denise and Audrey had the same amount of flowers. So that sibling rivalry looks like they are still tied. So Audrey had 972 flowers and Denise had 972 flowers. A moving company is hired to take 578 clay pots to a florist shop. The florist will pay the moving company a $200 fee plus $400 for every pot that is delivered safely. The moving company must pay the florist $5 for each pot for any pots that are broken or lost. If 6 pots are lost, 12 pots are broken, and the rest are delivered safely. How much should the moving company be paid? Okay, y'all, this was an exit ticket problem, and a lot of our scholars struggled on this. And I understand why. It's a lot of information that needs to be processed and broken down. So let's break this problem up and take it bit by bit, one by one, hara by hara. So I'm going to break it into parts. So before this black dash, we need to figure out that information first. So how much is the moving company going to get initially if they don't make any mistakes? So the moving company, they have to move 578 clay pots. So 578 pots. Let's write this information down in a neat manner. Let's organize our thoughts. 578 pots. So they're gonna get a $200 fee. They're going to get that $200 fee no matter how many pots they move. So that's standard. And then they're going to get $4 for every pot. So $4 times 578 pots. So this is how much payday, that's what they'll get on payday if they don't make any mistakes. We're going to take the mistakes out later, but let's focus on the work that they did. How much is the work worth? So let's do some math. 200 plus 4 times 578. Let's do that math. And you know I'm going to be using the standard algorithm because we need our practice. So 4 times 8. What is 4 times 8? That is 32. But that 3 is in the way. So I'm going to put it in the added. 4 times 7. That's 28. Plus the 3. That's going to be 31. But now that 3 is in my way, so I'm going to put it in the added. Four times 5 is 20 plus the 3. That is going to be 23. So I see here that the final answer is 2,312. But I'm not too confident in that because I just learned this standard algorithm. So I want to do an easy way to check my work. Since it's only 4, we could just add 578 4 times to see if we get the same answer. So let's do that. just to check. I like checking. And we get the same answer. Okay, so let's put that information in to our calculation. So the moving company, if they, at the beginning, this is the deal, that they get a $200 fee and then $4 for every pot. And since there are 578 pots, they will get 2,312. So the total would be 2,512. That's how much they get. But let's read the second part. They have to pay the florist $5 for any pots that are lost or broken. So 6 pots are lost and 12 pots are broken. Honestly, y'all, it does not matter if they are lost or broken. They broke this up to trick you. Do not fall for this trick. They want to make this complicated and make you question yourself. Have confidence. Believe in yourself. Never lost. Triple B. So it doesn't matter that they're lost or broken. It just matters that 6 plus 12 is 18. They were trying to trick you. Did not work. Next. So 6 and 12 are broken, but the rest are delivered safely. How much should the moving company be paid? So let's calculate their mistakes. We can call this damage fee. I'm going to put it over here now. Okay. So we can make it complicated like they want it. Remember, they have to pay $5 for each. So 6 times 5, that's 30. And 12 times 5, that's 60. That's $90. Or y'all, we could have done this. It would have been the same. So let me show you. Let me do the math over here really quickly. That's a bit too close. I want to make sure we are neat and we can see. Oh, sorry, y'all. Okay. 18, 5. We're in the ones place. If you're more of an array type person, $90. And the reason why it still works is because it doesn't matter. Remember, whether they're lost or broken, either way, you're going to have to pay $5 for each pot. So it doesn't matter if they were lost or broken. You're paying $5 either way. That is why the total is the same if you do 6 times 5 plus 12 times 5, or if you do 18 times 5. 6 plus 12 equals 18. So we are going to take their payday and subtract it from their damage fee. So the moving company, their final pay, we'll say final pay, equals 2,512 minus 90. That is going to equal, again, y'all, make sure you put the dollar sign and you put on the test that the moving company will receive $2,422. Make sure you put that dollar sign, because if you don't, we're going to be like, what are they getting 2,422 of? Are they getting 2,422 gummy bears? Are they getting 2,422 pots? What are they getting? This moving company is going to get $2,422. And remember, the dollar sign always goes in front of the amount of money. These are our final 2 word problems. So let's stay strong, and we are almost done, y'all. Each sandbag holds 27 pounds of sand. Oh my goodness, that is heavy. And it takes 53 bags to go all the way around Wilma's house. How many pounds of sand does Wilma need to fill the sandbags around her house? So the 2 factors, remember, that we're dealing with, it's going to be 27 pounds multiplied by 53 bags. So if she goes to the store and she needs to figure out how much sand to buy, this is the problem she'd do. So let's do the algorithm to figure out how many pounds of total sand she'll need. So she has 53 bags and 27 pounds per bag. And that's going to give us the total pounds of all the bags. So 7 times 3, that's going to be 21. But that 2 is in my way, so I'm going to put it in the added. Seven times 5, that's going to be 35, plus that 2, that's going to be 37. And I can leave that 3 there because there's nothing here that's in my way. Okay, now we're moving on to the tens place. And remember, I'm going to put the 0 here as a placeholder. 2 times 3, that's 6. And there's nothing to put in the added. 2 times 5, that's 10. So now I have 371 plus 1,060. So that we're going to add those 2 up. And our final number is going to be 1,431. So that's the total amount of pounds of sand Wilma would need to fill all 53 bags. 1,431 pounds of sand. All right. Our final one. A stack of 16 pennies is 1 inch tall. A typical man is 5 feet 9 inches tall. If you were to continue stacking pennies, how many pennies would you need in order to stack to be the height of a typical man? So they're asking us how many pennies. Let's put this in. They used confusing language right here to trick you. Do not fall for it. Y'all are too smart. So let's put it in simple terms. How many pennies does it take to reach 5 feet 9 inches? Y'all are too smart to fall for their weird. Oh, I meant to press question mark. Okay. So 1 inch equals 16 pennies. Look at this. We are right back to conversions. So we need to figure out how many inches, how many total inches are in 5 feet and 9 inches. Well, remember, 1 foot equals 12 inches. So we're doing 5 feet and 9 inches. That's going to equal 5 times 12 plus 9. That's going to be 60 plus 9. Total number of inches is 69 inches. Sorry, I'm just going to capitalize that. There we go. Okay, so now we know there's 69 inches. And there's 16 pennies in 1 inch. So 1 inch equals 16 pennies. And we have 69 inches. So what do we need to do in order to find the total amount of pennies it takes to get to 69 inches? We are going to multiply 69 with 16. And that is going to give us the total amount of pennies needed to reach 5 feet 9 inches. And I just want to clarify, the reason why we did 5 times 12 is because there are 12 inches in 1 foot. So if you have 5 feet, you're going to multiply 5 times 12 to get the total amount of inches, which 5 times 12 is 60. And we're adding 9 because it's 5 feet and 9 inches. So we're converting the feet into inches, which 5 times 12 equals 60. So 60 inches and 9 inches. That's 69 inches. All right. Now we're moving on to see how many pennies are in the total height. So 16 pennies are in 1 inch, and we have 69 inches. So we are going to multiply 69 times 16. Let's do that, and that's going to give us the total amount of pennies. So 69, 16. Start in the ones place. 6 times 9, that's going to be 54. But the 5 is going to be in my way, so I'm going to put it in the add it. 6 times 6, 36. But I still have this 5. 36 plus 5, that's going to be 41. I've used that 5, so I'm done. Now I'm in the tens place, so I'm going to put the 0 placeholder. 1 times 9 equals 9. 1 times 6 equals 6. We are going to add those together, and our final number is going to be 1,104. 69. Whoop, my bad, y'all. I don't know what happened there. There we go. 69 times 16 equals 1,104 pennies. So let's zoom out. Let's get a good bird's eye view of this problem. So the total amount of pennies, 5 feet and 9 inches equals 1,104 pennies. I'm going to make this a bit smaller. Oh, that was a lot smaller. My bad, y'all. Oh, that's bigger. I just want to make it pretty. There we go. So 5 feet 9 inches equals 1,104 pennies. So I hope y'all got a lot out of this video, and you can slow it down, rewind it, and take some notes. This is what you're going to use to study for your assessment. Use your notes to make it easier to study. Use your homework to make it easier to study. All right, y'all. Have a great weekend, and let me know if you need any help on your homework. And don't forget, go watch these videos if you need help with the standard algorithm. It has great graphics and makes it neat and organized.